and then a little more on mesenteries and peritoneal relationships and how different parts of the gut got to be where they are in an adult. And then we'll finish up with a last few notes about that posterior abdominal wall to get ready for Wednesday's dissection. All right, so the first organ that we skipped over last time was the pancreas. So probably not many of you saw the pancreas in your dissection on Friday. Did any of you guys notice it? You may have seen the superior part of it while you were digging around for the celiac trunk. But the reason you didn't see it is because the pancreas is retroperitoneal, and it's deep behind a lot of the other structures that we were looking at in the lab on Friday. So if we remove a bunch of these mesenteric structures, we can better see where the pancreas actually sits. And it has a close relationship with the duodenum, as well as with the spleen in the upper left corner. If you look at it in a cross-section, again, you can see why we didn't really notice it. And that's because it sits deep to that lesser sac, or that area behind the stomach. Right, like all of the other organs we've looked at, the pancreas has a number of named parts. So at the very distal most end, we call the tail. The main part of it is called the body. The big part that sort of sits in that curvature of the duodenum is called the head. This kind of indistinct part between the head and the body is called the neck. And there's a last part of it that we can't see very well here called the uncinate process. And this is a little part that folds back behind the head. And it's going to run back behind these two vessels here, which are our superior mesenteric artery and vein. Also nicely dissected out here, we can see the main pancreatic duct. And this will be a pathway for things generated in the pancreas to drain into the duodenum. We also have a small accessory pancreatic duct that will be present in most people, but the main pancreatic duct will be the one that we'll dissect out today. All right, now that we've finished up with the pancreas, we can link this to something we talked about on Friday, which was the bile drainage. So if you remember, we dissected out the hepatoduodenal ligament last Friday, and we found, hopefully, our common hepatic duct and our cystic duct. And when those two joined together, they formed the bile duct. And as the bile duct drains down towards the second part of the duodenum, it's going to join up with that main pancreatic duct in an area called the hepatopancreatic ampulla. And this ampulla is what's going to drain into an opening into the second part of the duodenum called the major duodenal papilla. The accessory pancreatic duct drains by itself in a smaller structure called the minor duodenal papilla. And you should be able to find at least the major duodenal papilla when we open up the duodenum, I think at the end of today's lecture. No, not lecture. Hopefully in the lab. No one opened up a duodenum in lecture. Okay, another organ that we're not going to deal with today, but we will deal with on Wednesday, are the kidneys. So here we can see the kidneys. Kidneys are retroperitoneal. So you won't see them at all today. Even after you remove your GI tract, you probably won't notice them. In this drawing here, we show them covered up with peritoneum, but they're clearly visible, which isn't really the case in most people. So we have both a right and left kidney. They are, as I said, retroperitoneal, so they'll be covered up with parietal peritoneum. And sitting at sort of the superior apex of each of the kidneys, we have a suprarenal gland. So we have both a right and left suprarenal gland. If we remove the rest of that peritoneum and what actually is a whole lot of fat, we can see this a little bit better. So our right and left kidneys have our suprarenal gland sitting right on top of them. If you look at it in cross-section, we get a better idea of what you're going to have to dissect through to see this. So here's our cross-section through the kidney here. And you can see that the kidney is embedded in this thick, multi-layered bundle of fat. So this is our left kidney. We have parietal peritoneum covering it up. We have two different layers of fat surrounding the kidney. The one that's pressed right up against it is called the perirenal fat. Outside of the perirenal fat is a layer of fascia that you don't need to know, that's the gray color, called Gerada's fascia. and that's going to separate the perirenal fat from the pararenal fat. So when we remove our GI tracts today, you won't see nice kidneys lying in the back of your abdominal cavity. You'll see what looks like kind of a wall of fat that you're going to have to dig through, probably on Wednesday. All right, we will at some point take our kidneys and section them so that we can see the internal structure. So this outermost portion is called the renal cortex. Then we have these triangular structures inside. These will usually be a different color, called renal pyramids. And from the renal pyramids is where we'll have drainage of urine into the urine collection system here. So each renal pyramid will be attached to what's called a minor calyx. Minor calyces will come together to form a major calyx. And then several major calyces will come together to form what's called the renal pelvis. And from the renal pelvis, we'll get a narrowing that will eventually become a tube that will extend down to the bladder, and this is called the ureter. We zoom in a little bit more. At the outermost part, we have a fibrous capsule around the kidney. And then we have our two layers of renal cortex, which will be this sort of thinner layer around the outside, and then a thicker medulla, or medullary layer. The medullary layer consists of these renal pyramids, and at the apex of each renal pyramid, there's a little point that we call the renal papilla, and this will be where the urine will drain from. And each renal pyramid, as I said, sits within a minor calyx. So within each minor calyx, you'll find a renal papilla. And then the tissue that's going to separate one pyramid from another is referred to as a renal column. So we have pyramids will be the triangular shaped ones, columns are column shaped.
What's the difference between the medulla and the pyramid?
So the pyramids are part of the medullary layer. So we have a cortex layer and a medullary layer. The pyramids are part of the medullary layer, so they're the triangular parts. All right, so back to vasculature. So we did part of the vasculature last Friday. So this first part will be review. Remember, a lot of our abdominal organs, or all of our gut tract organs, are going to get their blood from three main unpaired branches of the abdominal aorta. Celiac trunk we did last Friday. Today we're going to cover the other two, the superior and inferior mesenteric arteries. Everyone's favorite part of my last lecture, the development of the gut. Remember, we have a series of structures that are going to be fed by each of these different arteries. The celiac trunk is going to do our foregut structures. The superior mesenteric is going to do our midgut. And the inferior mesenteric is going to do our hindgut. And we'll go through the superior and inferior mesenteric in detail today. Another reminder that we have our three unpaired branches, and they all branch off at a distinct vertebral level. So the celiac trunk is going to branch off right after we get into the abdomen, so that'll be at vertebral level T12. The superior mesenteric will branch right below that at vertebral level L1. And then we have a bit of a gap until we get down to the inferior mesenteric, which will be at L3. Okay, so celiac trunk, as I said, we did last Friday. So why don't we go ahead and review very quickly the branches here. See how much you guys remember. So our celiac trunk had three main branches. We have this branch that comes to this part of the lesser curvature. What was this one called? Left gastric, good. And then we have this other one. Okay, go to the spleen, so that'll be the splenic. Coming off the splenic, we have these little guys coming up here. Short gastrics. This one. Left gastroomental, okay. And then what's this big branch coming off towards the right? Common hepatic. And then we have a branch coming down. Gastroduodenal. Let's see, branches of that. What's this one? Right gastroomental. This one. Yep. Superior pancreaticoduodenal. This one coming up. Hepatic artery proper, yes. Then this little guy coming off towards the lesser curvature. Right gastric. Our final branching of the hepatic proper.
Right and left hepatic artery.
Right and left hepatic arteries. Great. Everyone thought that was so much work last time. We all got it down pat. All right, so now we have 2 more to go through. But luckily, these ones are considerably easier, at least I think. Okay, so the superior mesenteric is going to feed structures of the midgut. So this includes a lot of the colon, as well as the small intestine and the duodenum, and other things attached like the appendix. And it will do a little bit of the pancreas. Okay, so here's a more realistic drawing of this. So here's our superior mesenteric artery coming off of the aorta. It'll send off a branch to the lower margin of the head of the pancreas called the inferior pancreaticoduodenal. And we mentioned this one on Friday because this will anastomose with the superior pancreaticoduodenal. We have another branch high up that doesn't show up well here because it's cut in order to show this, called the middle colic. And the middle colic artery is going to run to the transverse colon, which has been cut away here. So we'll see this better on the next slide where it's not cut away. Then there's a whole bunch of branches that are going to go to the ileum and the jejunum. And for simplicity's sake, we're just going to call these intestinal branches. So you don't need to differentiate which part of the small intestine it's going to. All of these ones coming to the small intestine are intestinal branches. Then we have an artery that's going to come over towards the ascending colon, the upper part of the ascending colon, and this will be called the right colic. And there'll be a branch that will run down towards the ileocecal junction down here, and this is called the ileocolic. That will send a branch off up towards the ascending colon called the ascending branch, a branch over towards the ileum, that'll be the ileo branch, a number of small arteries that will go to the cecum, which are cecal arteries, and an artery that will sort of run to wherever your appendix happens to be hanging off of the cecum, and that'll be your appendicular artery. All right, so that's it for our branches of the superior mesenteric. And again, like with the celiac trunk, branching patterns of these can be highly irregular, and we're going to name them for what they're going to. So if we have an artery that's going to the transverse colon, that'll be middle colic. If we have one coming over towards the ascending colon, the upper part, that'll be right colic. Branches that go to the cecum are cecal arteries, and so on. So here's a more diagrammatic view of that. So here we can see our middle colic coming off. These are hard to draw because the transverse colon kind of sits in front of all of these out of the plane. But we'll see that more easily when you actually reflect up the transverse colon to be able to see it going to it. Here's our right colic and ileocolic, in this case coming off of a common trunk. The right colic is oftentimes absent. A lot of times it will come from the ileocolic, or it'll come from the middle colic, or it'll come on its own. There's a lot of variability here. All right, another practice pathway. So the pancreas, as I said, is going to get blood from both the celiac trunk and the superior mesenteric artery. So we went over one of the ways that we can get blood there before. So blood goes through the celiac trunk, into the common hepatic artery, into the gastroduodenal, and then into our superior pancreaticoduodenal. There are also a couple other branches that we didn't talk about Friday that are going to come off of the splenic usually, called the dorsal pancreatic and the greater pancreatic artery. So there's a number of arteries that will come ultimately from the celiac trunk to feed the pancreas. And then coming from inferiorly off of the superior mesenteric artery, we have that inferior pancreaticoduodenal artery. So the pancreas is going to get a rich blood supply from 2 of our main abdominal branches of the aorta. Right. And the inferior mesenteric will be the easiest of these. This only does the hindgut, which will include the very last part of the transverse colon, the descending colon, the sigmoid colon, and the rectum. So here's our inferior mesenteric artery. This one will branch off quite a bit lower than the others. What vertebral level does this one branch off at?
L3.
L3. Okay. This will send a branch over to the descending colon called the left colic. A number of branches over towards the sigmoid colon called the sigmoid arteries, and a branch over to the upper part of the rectum called the superior rectal. And that's it for the inferior mesenteric. So this one is really easy. It only has a few branches, and they're named directly for what they go to. Left colic goes to the left side of the colon, sigmoid arteries go to the sigmoid colon, and superior rectal goes to the upper part of the rectum. And here they are again. So as with before, these arteries can be highly variable. So again, follow this rule of you name the artery for what it's going to. Don't just memorize the pattern in which they're supposed to branch off in the textbook. It's fairly common that we have certain branches will be absent and other adjacent branches will be enlarged to make up for that. And there's a whole series of anastomoses all around this region, and there's a lot of anastomoses between the inferior and superior mesenteric arteries. All right, so speaking of some of those, we have anastomoses between the superior mesenteric and the celiac trunk. We already talked about this one between the superior and inferior pancreaticoduodenals. But we can also get anastomoses along this greater curvature of the stomach between the gastromental arteries and the middle colic arteries. So that transverse colon runs right across here, across that greater omentum. So these arteries are actually going to be in very close contact. And we have a number of anastomoses between the superior and inferior mesenteric arteries. You'll probably notice that there looks like there's this one continuous artery that runs all the way around, connecting all of these different colic arteries. And that's true. And this is referred to as the marginal artery of Drummond. So each of the different colic arteries is anastomosed with the ones on either side of it. So we can get blood supply coming from a number of areas. And additionally, in some people, we have this extra sort of direct connection between the two of them. So in this case, from the middle colic over to the inferior mesenteric artery, called the arc of Riolan, which you don't actually need to remember. All right, so these were our three unpaired branches of the abdominal aorta, but you probably noticed that there are quite a few other branches back there as well. So these ones that we're going to go